Okay, welcome to another Sustainability Happy Hour.
Hi, everyone.
Hi, I'm one of your co-hosts, Pat Keys. I am the lead scientist at the School of Global Environmental Sustainability. And this is my co-host.
My name's Micah Bennett. I'm the communications specialist at SoGES. I don't know why I have the giggles today. We're going live on a bunch of different platforms, and so I'm maybe more nervous than normal.
That's okay. We're trying something new out.
We are trying something new out. So
what's life without a little excitement?
Right. So we are hopefully coming to you on YouTube and Facebook, and Periscope if we set everything up right.
And Twitch.
And
Twitch. I don't know if anybody uses Twitch. We're going to find out.
But anyways, we're happy to be here. If anyone is watching, feel free to chat at us in the comments. Tell us your name. Yep. Tell us where you're from. I know there are millions of you dying to be recognized on this. So go ahead and chat there.
Yeah. So if we don't get to you this time around, maybe wait a couple more million broadcasts, and then we might notice you next time. We're just kidding. Please comment, and we will definitely notice you.
Anyways, Pat, happy Friday.
Happy Friday. Happy Friday.
You got any?
Cheers to that.
Cheers to that. You got any fun facts for us today?
So exciting. Craig Starger, one of our loyal viewers.
Craig.
Thanks for joining us, Craig. Let's see, a fun fact. I am totally hilariously unprepared for a fun fact. Let's see here. You go first, and then I'll see if I can come up with something.
Sounds good. My fun fact is that I'm taking a Fort Collins staycation. Taking work off next week. Not going anywhere. Just staying here.
What does that look like? What's a staycation?
That's a great question. My parents are coming to visit, actually. They're driving here. They're not flying.
Okay.
But so we're just going to hang out and go on some day hikes, I think. But if anyone has suggestions for places I should take them or good social distanced activities we can do together, let me know. But that's my plan. That's my fun fact. Staycation.
Yeah, and I mean, this sadly, the whole pandemic takes on a new meaning of staycation, I'm sure.
It does indeed. Yeah.
Yeah.
You think of anything fun?
Oh, God.
You can pass if you want.
I'm gonna pass right now, and then maybe in the middle of the show, I'm gonna surprise everybody with a fun fact.
Oh yeah.
Yeah.
Good.
Okay.
All right. So now that we got that fun out of the way,
yes,
it's time to get into a different type of fun. Rocks. Rocks are really fun.
Rocks. Rock and roll.
We're gonna just do one news article today, and kind of a fun, interesting one. This is from the Washington Post. Spreading rock dust on the ground could pull carbon from the air, researchers say. Cool, you got that pulled up there.
Yep.
So this, I did not know about this. I did not know that this was a thing. It is called enhanced rock weathering. And it's when you spread rock dust on farmland into the dirt, it can pull carbon dioxide from the atmosphere. And based on the modeling that this group of scientists did, it says that we could reduce the amount of greenhouse gas currently produced by Europe, according to a major study published on Thursday. So when the rock is in the dirt, my understanding is that it gets rained on and then it dissolves. And then when the carbon dioxide is drawn from the atmosphere into the solution to form bicarbonate ions, that gets washed into the ocean where it forms carbonate minerals, storing the carbon indefinitely. So this is cool and important because with climate change and trying to keep the global warming temperature below that threshold, scientists are saying that we will need to not only reduce the amount of greenhouse gases that we are producing, but we are going to actually have to pull them back out of the atmosphere. And that's where rocks come in, because rocks rock.
So that's good, but I sort of feel like our viewers might be like, yeah, but why? What's the deal? Why is there so much carbon in the atmosphere?
Right.
And I know that I'm the lead scientist here, but I'm going to turn the tables right now and say, why is there so much carbon in the atmosphere? What's your guess, Micah?
Well, I heard it had something to do with fossil fuels.
Mm-hmm.
Mm-hmm.
Yeah?
Yep. I'm not a scientist, by the way.
It's okay. So in general, though, the problem is that there's too much carbon in the atmosphere because we're taking it from a place that it's been for a while, the Earth, and we're pumping it into the atmosphere, and it's accumulating there. And not enough is getting sucked down by the oceans or sequestered in the land. And so this is a way to try and pull more carbon out of the atmosphere.
Right. And why is carbon in the atmosphere bad, Pat?
Carbon in the atmosphere is bad because what happens is that the carbon forms carbon dioxide and a couple other gases that are really good at holding on to the heat of the sun, the energy from the sun. And then when they hold on to that heat, they start to wiggle around, and all of that can lead to increases in the temperatures of the entire Earth system. And we're going to talk a lot more about that later on when we bring our guest onto the show, which maybe we should talk a little bit about right now.
Yeah, I think that would be great.
Yeah. So with that, I want to welcome our guest, Dr. Zack Labe, right here. Welcome to the show, Zack.
Hi, thanks for having me.
Thanks for joining.
Thank you for joining. Maybe you could do a quick introduction.
Yeah, sure. So I'm a postdoctoral researcher at Colorado State, and my background is in atmospheric sciences. I just finished up my PhD at University of California, Irvine. I'm really interested in like large-scale climate variability. A lot of my work deals with climate models and looking at observations, and now I'm using tools like machine learning to try to interpret the climate model output. I'm also really interested in science communication, especially about Arctic climate change. A lot of my past research has been about the Arctic and how it may link to lower latitudes.
Cool. So we, if you didn't notice, just tried to give a little totally not staged at all explanation of climate change and what it is and why it's important, just to sort of try to set the stage a little bit. But can you tell us a little bit about your research and what you're finding in terms of where is climate going?
Yeah, so I'm looking at the Arctic, which is an area where we're seeing temperatures warm more than twice as fast as anywhere else on the planet. And when I first got into Arctic climate change, I really didn't realize, I guess, the speed of the changes that are ongoing in the region, both in terms of not just temperature, but the amount of sea ice that's being lost, the amount of land ice, like in Greenland, and the glaciers that's being lost. And I thought that these rapid changes have to be really critical for the climate system. And, you know, the Arctic it's an ocean. So there is no town in the middle of the Arctic. So we have a general lack of observations in this region. So this is an area with so many open questions, despite we know that these rapid changes are ongoing. And then lastly, there's communities that live around the Arctic Ocean and coastal areas. And these rapid changes are affecting these towns now. It's not something moving forward in the future, it's going to get worse, but it's already occurring now. I thought this is an area with so many things we need to better understand about the climate system. And that's sort of how I got interested in Arctic climate change.
So one of the things that I feel like we keep coming across, at least in the last, I don't know, month or so, is how incredibly fast things seem to be changing. And I think part of the challenge right now for people who are interested in understanding more about climate change and what the future is going to look like and how it's impacting different parts of the planet is that it's hard for people to tell the difference between, like, is what we're seeing happening in the Arctic right now expected? Is this kind of on track for what everybody thought climate change was going to be like? Because, I mean, if you haven't been paying attention, the Arctic is really hot right now, and the Arctic is not typically as hot as it is right now. So do you think you could spend just a little bit of time, I don't know, walking us through some of these words we keep hearing, Arctic amplification, and like, is this, what we're seeing, is this normal?
Yeah, sure. So although I said there's a lot of questions we have about Arctic climate change, we've known for decades that the most primitive early climate models were indicating that the Arctic was a region that was going to warm faster than the rest of the planet. And we talk about that in terms of this word Arctic amplification. And all it means is that the Arctic is warming much faster than the entire globe on average. And the reason that's occurring is due to all of these feedbacks in the Earth system. So when I mean feedback, and we often in climate science call it a positive feedback, that means essentially an acceleration. So the one I talk about the most for Arctic it's called the snow ice albedo feedback. And basically what that means is you have sea ice that covers the Arctic Ocean, which is a bright white surface. And when you have incoming sunlight during the summer, that bright white surface tends to reflect a lot of that sunlight back out into space. So it acts sort of like a refrigerator, you could say, at the top of our planet. But now that the climate is warming due to the fossil fuels and greenhouse gases like carbon dioxide, that even little bits of warming is melting substantial amounts of sea ice. So now you remove the bright white surface and you're left with this dark ocean. So now when the incoming sunlight during the summer is coming towards the Arctic, it's being absorbed in that dark ocean. Then the ocean itself is heating up. And then during the winter, when the sea ice starts to reform, a lot of that heat that was absorbed into the ocean escapes back out into space. And so that's been the basic theory for Arctic climate change, again, since these primitive climate models in the 1970s. And overall, for instance, this extreme event we've been hearing about in Siberia with the 100 degrees in Siberia, it's an example of a weather event that's superimposed on a long-term trend of warming. So while an extreme event is flashy in the news, as a climate scientist, I really want to emphasize long-term trends, is that the Arctic is warming in the long term. Every single year might not be a record warm year, but overall it's gradually warming. And that gradual warming increases the chance for extreme weather events like we're seeing in Siberia. So I would say, no, I'm not surprised about this Siberian heat wave. It's an example of an extreme weather event on top of this long-term warming.
And of course, it happened in 2020.
Yes, right.
Because 2020 is just a grab bag of horribleness, right?
Yeah, I had to throw out my bingo card because I filled the whole thing up. And so now I'm just looking for new things.
And so you're talking about Arctic amplification. It sounds just sort of like a cycle that feeds in on itself and amplifies itself, as the name might suggest.
Yes.
Interesting.
And so you just said something though, which was, so every year might not be a record-breaking year, but the gradual trend, and when you overlay some of these extreme weather events on top of that gradual trend, things can appear to be, or actually are, much worse than they have been in the past. So I guess one question though is, and I'm relying heavily, by the way, on a lot of the graphics that you make and distribute on Twitter. But when I see some of those graphs, it really does. Like, it looks like maybe not every year, but almost every other year is a record-breaking year. And so what, is there something you can talk about in terms of how the Arctic might be distinguished from other parts of the planet? So why might the Arctic be more sensitive than, say, I don't know, Colorado?
Yeah, right. So I can give an example in reference to this year, and it goes back to this feedback idea I was talking about. So right now we have this huge area of open water near Siberia due to this heat wave and other weather extremes. And so what's happening is this area near Siberia that's normally still covered by sea ice is now that open ocean. So it's absorbing all of that incoming sunlight. And we have observations that are telling us that the water temperatures of that part of the ocean are heating up, 5-6 degrees Celsius above average. So what's going to happen is, as winter approaches, so sea ice, it does grow in the winter. It has a cycle where it grows in the winter and melts in the summer. That's totally normal. So this fall, when temperatures finally cool down and we go back to polar darkness, sea ice will try to regrow. But now we have this warm body of water that is much warmer than average because of what happened during the summer. So it's going to take longer for that sea ice to grow. And because then it's going to take longer, then the length of the winter time that sea ice has to thicken is going to be shorter. So by next summer, when it starts warming up again, that sea ice might not be as thick as it was in the past year because of this shorter winter. And then it just is a feedback. So then the sea ice is more thin next summer, so it's more susceptible to any warmth. And it just continues and continues year after year. So that's one of the reasons, is because of these feedbacks between the ocean and the ice and weather. That's really why the Arctic is susceptible to this change.
And I think on that topic of some thinking about the sea ice and how there's almost like this time dependency, right? So what happened the year before matters for this year. But can you tell us, like, how old is maybe the oldest sea ice floating around in the Arctic? I mean, roughly, right?
Yeah.
Do we have estimates of that? And if so, what are they for kind of the old ice?
Yeah, we do have estimates. So some of the oldest ice in the Arctic, 4 or 5 years old. What's interesting is that the Antarctic in the southern hemisphere also has sea ice, but the sea ice is much younger in that region. It actually melts because it's a continent, which is the Antarctica, and then the Southern Ocean, whereas the Arctic is an ocean surrounded by land. So anyways, what I was trying to say is that in the Arctic, not all of the sea ice melts out every single year. But now that the climate is warming, we are losing that 4 and 5 year old sea ice. And now the sea ice is much younger. It's predominantly only 1 or 2 years old. And it's almost transitioning more to like an Antarctic sea ice environment. And a lot of scientists are trying to call it the new Arctic, where we're seeing the ice become not as old as it used to be, and thus more susceptible to extreme events like this heat wave this year.
Okay, I want to remind everybody that if you have questions, this is a perfect opportunity. Type them in whatever platform you're watching on, and we'll see them here. And we'll go ahead and try and get Zack to answer those. I guess in the meantime, one of the things that when you think about sort of the next step, so like, what do you think the next 10 years might hold for Arctic sea ice in terms of thinking about these changes that are unfolding, and kind of you got this gradual background increase in temperatures with these extreme events that happen to sort of have these inflection points. I mean, in your mind, what do you think 10 years from now? So let's say we meet again, our wildly successful live stream broadcast continues for 10 years, and we invite you back in 2030. Oh my God, I think we'll be doing something. We're gonna have like holographic projections or something. But like, what do you think it's going to look like? 10 years from now, same time, July 17th. What's your kind of? I mean, I don't want you to. I don't want you to feel like you're tied to some forecast here, but I mean, just off the top of your head.
I really think we're going to be seeing this idea of the new Arctic, where it's just predominantly thin and younger ice, and that's going to change. It's going to change the marine ecosystem, the surrounding coastal ecosystem. It's going to change how indigenous communities rely on the ice. So this transition from older, thicker ice, which has been reliable for these communities that live in the Arctic for hundreds of years, is now going to be really thin and susceptible. And I keep going back to this one extreme event, which was winter of 2018 in particular, where in the Bering Sea, which is a region in the northern Pacific Ocean, it's between Russia and Alaska. And essentially the sea ice just wouldn't form in the Bering Sea like it had done in our observations for at least 150 years. And there are so many indigenous communities that live along the Bering Sea in Alaska. And I was struck to see the impacts to these communities, and it ranges all sorts of things. For instance, the ice acts as a barrier for these towns against coastal erosion from storms. They rely on it for transportation, for hunting. There was one picture where for decades of years, there had been a little airstrip that this town relied on to get supplies during the middle of winter because there's no roads. And it normally was on top of sea ice. And in February, someone took a picture and it was just the open ocean. So I envision in 10 years, these types of impacts to become more severe, and which will require significant adaptation for animals, humans, all sorts of things that have relied on the Arctic.
Yeah, I just want to pull up this picture of sort of the Arctic basin. And so you were just talking about the Bering Sea, right?
Yes.
Up here.
Right.
And so I guess one thing that you mentioned in passing was these ice roads. And in the winter, ice roads are critical forms of infrastructure for indigenous communities, for oil exploration, for all sorts of activities in the Arctic region. Ice roads are they can just sort of like make roads and just go everywhere in a way that you absolutely cannot in the Arctic, because in the summertime, I mean, what does the Arctic look like? It's filled with, it's like kind of like a gigantic wetland in vast parts of the Arctic, and you're not driving across that. So I guess one thing that strikes me, especially like this image, is this is sort of a vision of what the future is going to look like in terms of an ice-free Arctic, and the significant changes that's going to hold for all sorts of activities, infrastructure, everything, biology, indigenous communities. So I guess to take that idea a step further, in your mind, in your understanding of the Arctic, I think it's reasonable to expect something like this, by the end of the century? An ice-free Arctic?
Yeah, I get a lot of questions about ice-free Arctic, so I'll clarify. Climate models currently project the best chance of an ice-free Arctic during summer, and that would be sometime mid-21st century, and most greenhouse gas emission scenarios are pretty similar. If we do reduce the amount of future greenhouse gas emissions, we reduce the chance for an ice-free Arctic, but it's still looking more likely than not by mid-21st century, the first time in summer that occurs. What's interesting, though, going back to this new Arctic, is climate models actually show sea ice across the ocean during winter, at least through 2100. So I wouldn't anticipate the ice-free Arctic to be year-round. I think it's going to be if it occurs, it'll be a summertime event, which is going to have major impacts, of course. But it will regrow a little bit in the winter, but thinner, again, and more susceptible, back to that idea.
Yeah, I just, even the changes that are happening right now, the changes in sea ice have already changed things so dramatically when you think about the species that depend on that like land-sea ice interface and that need to be able to hunt on the ice and maybe come back to land. And then the communities that are all over the Arctic, particularly in northern Canada and Alaska, that need the sea ice for hunting purposes, et cetera. I guess even if it's not gone by the 21st century in the winter, I just think that this region is going to change so much. And actually, you just said something. This is not technically part of what we were going to talk about, but I know that you're part of some projects that is part of this sort of like navigating the new Arctic, or you've been kind of involved with this process. And you've said the new Arctic, or what did you say? Yeah, the new Arctic, right? Yeah. And so there's this big NSF program right now, National Science Foundation, that's looking at supporting projects around sort of navigating the new Arctic. Do you want to talk at all about some of your experiences with those projects? Right.
My experience has been a lot involved with sea ice thickness. I know I keep mentioning it, but one of this navigating the new Arctic ideas is that shipping will increase in the Arctic Ocean. So as the ice continues to thin, we're going to see an increase in boat activity across the Arctic. And it's pretty obvious why that would be appealing for shipping, is because it cuts down time going from the Pacific to the Atlantic Ocean. And we're already seeing impacts from Arctic shipping going across, like we call it the Northern Sea Route, which is this shipping lane that goes along the Siberian coastline. And that's an area that's already seeing increases in shipping. So this project is really to understand all of these different types of impacts, this word transdisciplinary impacts from Arctic climate change and Arctic system change. So encompassing how it impacts people, how it impacts the economy, how it impacts politically. All of these are important topics to understand for Arctic climate change. And honestly, it's one of the things that appeals to me about understanding this, because you get to work with so many different fields to try to understand the effects of all of these changes. And this is a great map. So the yellow one, that's that Northern Sea Route along Siberia. And this year, because of the heat wave, you probably could take a ship through there already this year. And then the other side, towards the North American side, that's the Northwest Passage. I know a lot of people look to see if that melts out during the year. And sometimes in that area in northern Canada, the ice is pretty thick. So it doesn't melt out every single year. But in the future, I could envision drawing a color line straight through the middle of the Arctic Ocean. And one of the things about that, if you're a ship up there and something goes wrong, there was some cruise ships going up in the Arctic the last couple of years. There's nothing out there if something goes wrong. The Coast Guard is very far away, and these are all environmental hazards, all sorts of things to think about. So this National Science Foundation project is trying to understand a lot of these changes.
If you are just tuning in with us, we're talking with Dr. Zack Labe about climate and atmospheric science. Zack, I kind of wanted to ask you about more about you and what you're doing right now, and sort of how you got interested in this in the first place.
Yeah, I can give a quick bio about me.
Yeah.
So I've always been interested in weather. I was in elementary school giving the morning announcements for weather forecasts. I used to run outside in thunderstorms, stay up to 3 a.m. secretly and watch snow. I have journals of my weather observations hourly for a couple of years in a row. And I went to college then to study meteorology. I thought I was going to go into weather forecasting, and then sort of change things around by trying out just kind of randomly a research opportunity with a new professor. And he introduced me to using climate models. Honestly, I'm from a somewhat smaller town in the middle of Pennsylvania, and I didn't know anything about climate change until I got to college. To be honest, it wasn't talked about at all, and I never had heard the word really in high school. So I didn't know anything about climate models when I started this research. And it was awesome. Obviously, I like it. I'm doing it now. My project was looking at changes in the timing of spring in North America and how it's going to affect agriculture and plants blooming.
Across the whole continent, or?
Mostly United States. It used this public science database of plant observations to see how they're changing. And I used a climate model to look at that, how it's going to go forward into the future. So I thought, well, then I think I really like this research in climate models. So I was going to apply to grad school in a climate-related program. And my program was called Earth System Science, but it's basically climate science. So you learn about the oceans, the biogeochemistry. So it was instead of just studying meteorology, the atmosphere, this was a nice broader view of climate science. And my project was really about using climate patterns in the North Atlantic Ocean and in the Arctic to try to understand how that's going to affect the weather in the mid-latitudes, so like North America and Europe and Asia. And as I got into the project, I learned more about the Arctic and how rapid the changes were, and how so many questions we just don't know. We don't even really have that great of an idea of sea ice thickness going back that many decades. So there's so many open questions, and things I would be studying in 1 year about the ice would totally change by the next year. So that would just blew my mind. And
like what? Can you give us an example?
I don't have a personal example, but someone I know I forget the name of the glacier, said he studied the glacier for his PhD, and then like a decade later, the glacier had just basically melted. A small glacier, but nonetheless, it's just how rapid the changes are ongoing. And I started noticing that if you follow these in real time, the Arctic, like CS, track it daily like I do, a lot of people don't realize how wild these changes are occurring. So I started making graphics of sea ice and temperature changes in the Arctic every week, providing updates, and sort of just became interested in communicating how rapid these changes are and why they're important, and hopefully why people should care about them. And it's sort of how my research interest develops. And so I'm still interested in this interconnection between climate change and how it impacts weather.
So that was a perfect segue to this whole thing. So you say that you're like just a climate scientist, mild-mannered, studying ice, and yet And yet, there aren't very many scientists that have 27,500 followers on Twitter. You are a kind of giant in the field of climate change science communication, particularly Arctic climate change science communication. I mean, these figures that you've created and these updates that you said you were creating, they're used by, like, you name a major news outlet, and it's used some of these visualizations, which, I mean, it speaks to how good the visualizations are, but it also speaks to your desire to be a science communicator. So I'd sort of like to pivot to that a little bit right now and kind of better understand what you have done to kind of plug into this. Where did this interest come from? Because clearly, I don't think you'd stick this out to kind of be this sort of big of a communicator if you didn't have a passion for it. Because I know, because I do not have 27,000 followers, but I commented on one of Zack's posts a few weeks ago, and then I was inundated by a lot of kind of negative feedback. And so I imagine that you receive quite a bit of negative feedback. And so that would scare people away, some people away. Like, I don't want to do this anymore. It's not worth. But clearly, you have a passion for understanding these and communicating that passion. So, do you think you could speak a little bit about that?
Yeah. So how I got started is kind of comical. It started first year of grad school. So when you start grad school and you finally arrive at some sort of project, most of your time initially is reading papers, science paper after paper after paper. And I was just getting really frustrated at the graphs in the papers. I'm looking at these Arctic papers, and there's these huge dramatic changes, and I can barely understand the graph. And
it's like, you maybe like you have like 30 figures, and they're all like the size of your fingernail, and it's like, there's my paper, here you go.
So I think
please understand it.
Exactly. My increasing frustration thought, honestly, I don't know anything about graphic design, or I have no training in communications, but the increasing frustration I had with these science papers, and then also looking at observations of changes in real time, thought, well, I'm going to try to make my own graphs and just go based off of kind of what I find appealing at first, to be honest. And I actually have saved the evolution of it shows the same plot, but how I've changed how it looks over time. It's kind of comical.
I mean, that sounds awesome.
Yeah, it's good for me to see. Like, I can look back at the same graph, how it looks what I looked like 3 years ago, and some are pretty bad. But I've improved.
Did you change like your favorite font?
Oh yeah,
Were you using Comic Sans?
No, I have never done that. But I use the default Python font. I don't know what it's called, but not my favorite. So now, if you notice, you can always tell my graphics. They have a black background and the exact same font.
Yep.
And so do my presentations too for science talks. And I don't know how I got on the black background. I think it really pops so you focus. The goal of my graphs is basically, one, to tell a story. So most of my plots, not all, but most of them, I want you to see what's going on now in 2020, but I want you to compare that to what's happened over time. Because my goal—
Let me see if I can find a good one of those. Oh, like this one.
Yeah, that one's a great one to focus on. So you can see 2020 is an extreme event, but you can also see how it's changed over time, and that's where the colors come in. So as long as you know that the lines, each line is 1 year, the purple lines are older years, and then the whiter lines are recent years, then you can see that while 2020 is an extreme event, over time, it's been getting less and less sea ice. And I don't want people to really focus too much on the axes necessarily, but really, what do the colors tell you? Colors really tell a story if you do it right. And I hope my graphics, you can look at it, and once you figure out initially what's going on, then they tell a story, and you don't need to worry about, oh, what is 10 to the 6 kilometers squared? I want you to just take away that the sea ice is declining over time, and this year is a particularly unusual event.
Yeah, and you can see, and I mean, they're also just aesthetically beautiful. So it's really surprising to me that you haven't had any kind of graphic design, like
they would make really
training
cool
or
album
anything.
covers.
Yeah, they would. maybe like an emo group or something. I'm not sure.
Yeah, like kind of like a punk rock type of thing.
Yeah. This is an interesting one because I think you mentioned on Twitter that like this year might potentially see no sea ice.
Right?
In the lab. No, please interrupt me, please.
Sorry, in this region,
No.
yeah, you can see something I also like to point out for this particular graph is check out what happened in those purple lines. And so the end of summer is when the sea ice decreases the most. And then as you can see, it refreezes when the lines go up in October. So in early September is the minimum amount annually every year. But compare those dips in the 80s to 2020, and we're only in mid-July. So it's just, to me, it's so striking to see how much has changed in the last few decades, just based on how the minimum, we're not even close to what it was in the 80s. And we still have 6 to 8 weeks left of melting. So again, I guess that's really what I hope people take away from my graphs. And honestly, I'd rather people not focus too much on 2020, but really just focus on the trends. That's when I talk to journalists or the public, that's what I really want people to take away from me is we can use our records going back 40, 50 years, and we know that it's not just one outlier year. We know that this is something more significant over time.
We have a comment. Not a serious comment, but again.
But this isn't a serious show.
This isn't a serious show. That's a good point. Thank you, Micah. Craig says, emo is dead, Pat. I wouldn't know. My musical tastes are different. I'm a big fan of Weird Al. I don't think I'm going to know what's popular or not in any decade at all.
Zach,
okay,
Zach,
so
do you have a favorite song, Zach?
Oh, yeah.
No, my songs are actually like 90s and 80s too, so I don't know what's popular now either.
This is a safe space to talk about that.
It is.
Okay, so the show's gonna end in about 10 minutes, but I guess one of the things I would love to know, because you are a postdoc right now, which to our audience, if you're not in academia,
I still don't really understand what all that stuff means.
Yeah, so let me describe it, and then Zach, you can be like, that's wrong. This is what it means. So what you do is you get your undergraduate degree, maybe you get a master's, you get a PhD, and after you get a PhD, one of the things you can do is go become a postdoc, which means essentially you have a 2 or 3 year project where you maybe learn something a little bit new, but you have demonstrated that you're good at asking and answering questions with a PhD, and now you can go ask and answer some new questions with a new advisor, probably in a new place for a little bit of time. What do you think? Is that?
Yeah, that sounds fair. Sometimes I don't understand what a postdoc is either. So
yeah, that's fair. So you're going to do this postdoc, for a couple of years. What do you want to do next? You've got all of these different directions that it feels like your work could pull you in. You've got sort of like a systemic interdisciplinary understanding and appreciation and interest in the Arctic. You've got your significant climate change work. You've got your kind of science communication. All of those things could be their own thing. So I'm just sort of curious, and you're at the beginning of your postdoc, so you've got time to shape what you want to do. But where do you think you're going to end up going?
You could also design album covers.
I guess I could. Honestly, I don't have a good answer. I love research. I like looking at the data, but I also like thinking, okay, how can I share this data with others and make it pretty? So whatever I do, I want it to make sure that I can share my work with others and that I share the significance of it. I believe there's significance in everything we do in science, not just climate change, but all science. And I feel like I should be able to give back and share what I'm doing and how I do it. That's really important to me too, is not just make the graph, but I also try to share how I made it, like computer code, with others. So I'm still trying to find out what is that position where I can still do really cool science, ask new questions, and share it with others. Like, that is part of the job that I do. So I don't know what it's going to take, where I'm headed yet.
Well, on that note, we have a question from Randall Barnes. How can you make such impactful graphics consumable to those who are visually impaired? It's a great question. And I mean, so some of these, so like I'll pop up the figure again. Like, what are some ways you could make this kind of consumable by people that maybe can't see all the color spectrum, or maybe they don't have any visual ability? I mean, off the top of your head, do you have any wild ideas?
Yeah, so on Twitter, there's an option for alternative text. So for screen readers, for visually impaired, it offers an option for what is being shown for like an animation or a picture. So all of my tweets take advantage of this great feature that's offered on Twitter, and it has it's like a caption. Sometimes I'm not always sure how the best way is to write it, but I essentially try to write what my graph is showing. So like that graph right there, I'll say it's a time series graph with a line for each year showing sea ice changes in the Laptev Sea. One other method for colorblind, I always make sure my colors are really chosen to make sure that's possible. So be aware of colorblindness. Rainbow graphs are a really big problem in science, so I try to stay away from that. For instance, when we show if it's warmer or colder than average plots, I make sure to include contrasting colors like red and blue. Red we feel is warm, so warmer than average, and blue we feel cold. So these are just a few of the methods I've tried to use. The alternative text is a new feature I just learned about over the last year, and I've really been trying to do that for every animation and figure I make on Twitter. Should work, I hope.
Have you received any feedback? I mean, honestly, that's astonishing that you've also gone to the effort to do that too. But have you received any feedback like this really helped, or?
Yes, I had someone message me and said that you're one of the only scientists that's actually taking advantage of this feature on Twitter, and they thanked me because they utilize it. So I encourage, it's not obvious that this is a feature that is available. It's somewhere in the settings on Twitter.
I was just going to say, this is probably not the time to walk us through it, but
yeah, it's somewhere in accessibility settings, I believe, and you just turn it on, and then when you put the plot there, it'll give you an option to write like a hidden caption that only screen readers can use. So yeah, I think some people have, it's been useful.
That's wonderful.
Can you?
Okay, so if you're a scientist, do this. Do what Zack did.
You had talked about rainbow graphs used in science a lot. Can you talk about why those are not great for accessibility?
There's a couple issues. One being the red and green are particularly one of the most common colorblind visually impairedness. So the red and green, they can't be distinguishable. And another problem with those rainbow graphics is they often create sort of boundaries for the colors that should not really be there when we're interpreting. It gives us kind of a misinterpretation of what's being shown, where if you include a more smoother color change, it takes away these features that we're picking up on visually, but we really are misinterpreting the data, in my opinion. So that's just a few. There are lots of various colorblind challenges for colors, and there's great websites where you take your figure, you pop it into this software, and it kind of tells you, if it's colorblind friendly or not, and gives you tools to solve the issues. So I encourage, it's kind of cool, and it's really simple and easy to do.
And a great website that I've used is actually something called Color Brewer. Let's see, colorbrewer2.org. And so you can choose kind of the types of color schemes that you want to try and find. And then you can also sort of select what's going to be friendly for people that are colorblind, what's going to be print friendly even, or photocopy, all these different settings to make sure that the colors that you choose to use in your scientific communication can be kind of created appropriately to meet those different needs.
That's really cool.
Yeah, I totally use that website.
Yeah, I know. I use it all the time.
We are nearing the end of our broadcast. Oh, we got one more comment.
We got one more. Let's see it. Craig Starger says, alt text is available in many programs now, PowerPoint, PDFs, etc. Great teaching tool. That's a good point. Yeah, for teaching a class. I mean, everybody's teaching online now with all these digital resources. And so it's a great idea to think about how can we make this content more accessible. Thanks for that, Craig. And
depending on who you work for and what your institution is, you may be federally required to make sure those things are accessible as well. But I was going to say, we're nearing the end of our broadcast, and we haven't asked our favorite question yet. Pat?
Is this where I ask him what his superpower is going to be? No.
No. That's
other. Oh, that's the other question. That's the other question. Okay. So we always ask our guests. So we're all in this crazy, like absurd lockdown situation, right? Still, and probably still for much longer. So what's something that's like maybe happened during this time that makes you happy or that gives you hope or something like that makes you kind of see our world in a more positive way?
And it doesn't have to be science or sustainability.
No. It doesn't have to be science or sustainability
Maybe
related.
you saw a really cute dog on the sidewalk.
Yeah. Bonus points for cute dog.
Mostly outdoors things. I try to spend a lot of time outdoors. I'm on the computer all day. And now that we're in lockdown, I'm really on the computer. And so I always get joy of being outside in parks. And sometimes I want to be alone, but I actually really like seeing other people outside and families outside. When I was young, I have some of my favorite memories of fishing in ponds with my grandparents. So I kind of always get excited when I see kids fishing because I know I had so many memories doing those types of things. And that's what's kept me happy. Selfishly, I keep a routine that on Friday evenings, I always get takeout from a local restaurant and then watch scary movies. It's sort of a guilty pleasure the rest of the evening.
That's great. That is
awesome. I love how getting takeout now is like you're supporting local businesses, right? It doesn't just mean you're lazy and you don't want to cook. Is there anything we didn't touch on that you make sure we get to?
No, I'll bring it back to science. One point I want to make, since I get this question so many times. It's about back to the ice-free Arctic, when's it going to happen? And I like to tell people the impacts are happening now, and they're gradually getting worse as we lose more ice. When the Arctic becomes ice-free, it's not going to be a switch that all of a sudden everything goes bad. We should be concerned with any loss of sea ice. Any amount is going to have impacts. And so I like to really emphasize that point is we should be concerned now about these changes and try to prevent an ice-free Arctic, but regardless, the impacts will still be there.
Right, you don't want to wait till everything gets so bad that you can't ignore it anymore.
Yeah,
that's a great point.
Yeah.
Well, thank you so much, Zach, for being on the show. I feel like I want to have you on, maybe at the beginning of the next season, be like, how did everything shake out in terms of the sea ice season, but also like what's it going to look like? Maybe we'll coax you back onto the show next year.
Yeah, that'd be great.
Thank you again for being on the show.
Thank you.
And happy Friday.
Go get some takeout and watch some scary movies.
Thanks.
Bye.
Okay. Bye. Okay.
Well,
that was like, I learned a ton.
Yeah.
Also, I feel like
Oh, go ahead.
No, please.
I was gonna say I didn't know that about rainbow graphics. I know some things about like color accessibility, but what he was saying about how those colors, it's not even an accessibility issue. Like it can actually make you interpret the information in a way that it was not meant to.
Right. Yeah.
But yeah. Anyways.
And it's sort of changing. Actually, there's a couple software that are commonly used by different scientific communities, and now the default is no longer the rainbow like graphic color bar.
Interesting.
But yeah, anyway, what a good show.
Yeah. Well, that's about all.
Do we have any announcements?
Do we have any announcements? That's a great question.
Let's see. We can announce who's going to be on the show in 2 weeks.
We can do that. Let's do that.
Why don't you do that?
Okay. 2 weeks from now, and actually it's going to be on a Wednesday, not a Friday.
Everybody update your Trapper Keepers.
Update your Trapper Keepers. It will still be happy, and it will still be almost an hour. So it will still be the Sustainability Happy Hour at 3:30 on Wednesday, July 29th, I think is what it is.
Sounds right.
Anyways, we are going to have Julie Kallenberger. She is with the Colorado Water Center, and she's going to talk about water and water education, and it's going to be a good time.
Yeah, it should be a great show. So we will look forward to seeing you in 2 weeks, but until then, go get your takeout and go watch some scary movies or whatever kind of movie you want to watch. Okay.
That sounds good. All right.
Well, thanks for joining us, and we'll see you in 2 weeks.
Thanks. Bye.